My name is Ben Vigoda. I'm the CEO of Gamelan, and we are developing the next generation in deep learning and machine learning. And we're applying that to bringing data together, essentially automatically and autonomously processing data from many different sources and joining it. So my experience at MIT, doing my PhD at the MIT Media Lab with Professor Neil Gershenfeld, we built the first probability-based microchips, and they were really the first microprocessor architecture that was specifically designed to perform machine learning algorithms or applications. And that grew up into my first startup foray, which was called Lyric Semiconductor. And we eventually grew up and joined a larger organization, Analog Devices, and put the chips into all kinds of everyday objects and products, which probably everyone uses. Phones and cell phone base stations and cars and so forth. And one of the things I learned from that experience was that hardware and software go hand in hand together. Venturing out to start my second company, Gamelan, was really going back to software from hardware, going back to the algorithms and saying, now that we've seen how these initial algorithms compile onto hardware, can we re-envision the design flow and the tool chain for implementing statistical machine learning and deep learning? Gamelan has currently, we're not using any hardware, special hardware. We use the cloud, and we're actually portable across all of the different public clouds. So we run on Google and Microsoft and Amazon clouds and so forth. And there's a lot in common between the parallelism that happens inside of a specially designed chip and the parallelism and kinds of communication patterns and so forth and compromises that you have to make when you have lots of machines in a data center in a cloud. So there's many interesting technological relations there, but Gamelan is a cloud SaaS company. And you know, two things about that. One of the things we do is people can upload database extracts, CSV files, Excel spreadsheets, and so forth, and just kind of dump them all up onto this web page. And our machine will read through it all, and it'll give you back a single, unified, perfect spreadsheet with, you know, if there was one spreadsheet initially had some information about a person and maybe where they lived, and another one had maybe an address and, I don't know, something else like, I don't know, the cost of their home, then you could join those three things together now. Even if they were written differently. So even if they were written sort of in colloquial human language, not necessarily written out in machine code. And what we're really talking about with this new kind of machine learning is a way of bringing stories into deep learning. So it's what we call prior knowledge. So today, the state-of-the-art machine learning doesn't know anything until it meets the data. So it's a blank algorithm. It's essentially a tabula rasa, has no prior, almost no prior. And you give it some data, and it learns from that data, and it sort of shapes itself. But before you give it some data, you know, the same algorithm could essentially run on audio, video, text. I mean, very similar. Whereas human thought probably, and we think the future of machine learning lies in the machine actually knowing some stuff. And so we call those stories, and our machine learns stories from data, but then they're articulated in the system. So we can go in and read the stories it's learned. They're written in Python, and we can see what it's thinking. And when it goes and applies the stories it's learned to future work that it does, you can have a good sense, like a human expert with a certain background, you can have a pretty good sense of what kinds of background or prior sort of leanings or ideas it's going to bring to examining a new piece of data.